If I take all the dust in my house, no, not that, that would be silly. We're very serious here. If I take all the dust and shrink it down, I have about this much. But how did I know? And what did it taste like? Ugh. I've always wondered, what is the air in this room like? Is it wet? Is it full of dust? Is it good to breathe? Is the air outside even better, or is it worse? I mean, I do live in a city. And how will I know that? Well, I figured it out, and by the time I tell you how, you might think I've stolen something. Oh, maybe I am full of dust. It's this thing! And there are more. Here, behind this door. And also here, in front of this door. And there's one right here. Above what I'm going to tell you is a small pile of neatly tidied items that definitely isn't in the way of me filming this small segment of the video. There's even one all the way up here near the ceiling, which, even with this conveniently placed video light, means I wouldn't be able to see the screen that isn't on the front of it. That's a weird choice of phrasing. Yes, and I'll explain. Not yet. So what are they? They are air sensors, and that does seem a little bit of an understatement because the amount of stuff they've got inside is pretty impressive. If you take a closer look at one of these boards, there are 1, 2, 3, 4 sensors on there, and those sensors don't just measure one thing. This one measures 4, I think. This is an indoor air sensor designed by a company called Air Gradient, which you can clearly see once I've actually moved the thing out of the way. I didn't buy it from them. I stole it. Not quite. So, the keen-eyed amongst you will notice this is an open source piece of hardware, which means they release all of that information, what's on it, what you need to put on it, how to make it, and in a way, how to sell it, for free. You can do that. They are fully aware of it. That's what open source means. You put it out into the world, and what will be will be. You might wonder why. Commercially, it doesn't seem to make sense. Why would a company release all of its product designs for anyone to use and sell? All of the plans are out there, open source, including 3D printable cases. They're slightly different from the ones you'd buy commercially, but they work really well, and the attention to detail, like this little cable groove in the back, is really good for something that they're not producing. That is given away freely. This isn't the case as you would expect to see on the Air Gradient model if you bought it from them. There should be a screen on there, but I didn't really want one. As you can see, I've got these all around my house, and often in places that you couldn't even see a screen. Now, I've got something called Home Assistant running, and that's great because I can have it on a screen that I carry around with me. And the joy is, because it's all open source, I can modify the design they released so that I don't have a cutout for the screen. And I can modify the software so I can use the tiny bit of space that I've freed up, not having to include the screen software information, to do something quite cool. But let me tell you about how I made these first. Some of you will already know that this blue machine is a CNC router that is high precision and designed specifically to make printed circuit boards, or PCBs, which conveniently is what this is. Now, I didn't use it because actually it's much easier to use something like PCBway, a service that will print the boards for you. They can populate it with the components that you want and send them to you really quickly. Probably quicker than I could make them using that, because I'm not an electronics person. I can't even say the word. So how does this work? Well, Air Gradient supplies the files on their website for both the 3D printed case and for the PCBs, but you need to send them to PCBway and then figure out what they all mean. So let's imagine you're like me. You've never made a PCB before, but you've seen people do it. It looks quite easy, and it is, actually. Designing them, that's a different thing, but if you've already got the design files, sending something like this to PCBway is quite trivial, to be honest. All I did was download the files from Air Gradient, upload them to PCBway, and they walked me through the process and sent me this. Actually, they didn't send me this, they sent me something a little bit closer to this, but not with all of the components on. They've got a service where you can make a PCB and then have parts assembled onto it. One of the obvious things is this ESP32. It's the kind of brains behind the board, and while you can get versions that look a little bit more like this, they're bigger and they slot into things, this is the heart of it, and they can put that on your board for you rather than you having to find the bigger one and much easier to get them to do it. But I did spend a bit of my time trying to find a cheaper source for some of the components, like the dust sensor, temperature sensor, and volatile organic compound sensor. So it wasn't an entirely delivered product. I did have to do a little bit of making, and I quite enjoyed it. It gave me a bit of a challenge as a non-electronics person to populate the board with a few of the components, like this CO2 sensor. But let me show you how I did it. I've got 3 different versions of the air sensor in front of me. This is what PCB sent me. This is also something they sent to me, but more I think as a sample of the bare PCB. And then finally, the finished product. Now, let's start with a very basic one. If you're going to go down the self-manufacturing route, in other words, adding all of the components, this is what you're going to have to add. All of these bits down here. So there's a USB-C connector for charging. There are some headers, which I don't actually need. These are for the screen, but at the time of making this, I didn't really know that. However, there are connectors for sensors here, here, and here. This one I'm not using, and I'm not using any of those 3 either. So if you go down this route, then you could probably save yourself a little bit of money. So if you're the sort of person that has made PCBs or assembled PCB kits, then maybe you'll be tempted to do this one, but hopefully I've convinced you that the partially manufactured board is the best way to go, particularly for the intermediate or beginner. What's the difference here? Again, I've got some sensors plugged in here. These things I bought from AliExpress. They are a volatile organic compound sensor, a temperature humidity sensor, a CO2 sensor, and a dust sensor. This thing has got a little fan inside. Now you can really go into depths about figuring out what type of sensor you want. There are different versions of this dust sensor that have got temperature sensors, and you think, maybe I should include those, but I'd say stick with what They have done a lot of research trying to figure out what is the best sensor out there for an affordable price and comparing it to lab reference equipment. So let's break this down a bit more. The dust sensor here is arguably one of the easiest to mount. There are 4 screws on the back, which you don't actually need to include. I saved myself some money and some time by only including 2, and I've not had any problems at all. These are really rigidly mounted on something that's going to be on a wall and not moving. However, the cable that plugs in is a little bit difficult. They make note of this on the Air Gradient website that you'll need a crossover cable. This is a through cable, so things connect to the same port on both ends of the plugs. But for whatever reason, Air Gradient, you need them to rotate over. Of course, you can't just turn it around. You have to take each one of these little pins out and swap them from left to right. Now, I'll see if I can show you how you do that. If you look carefully, you can see there are tiny bits of metal popping up through the plastic here, essentially locking the connector or the crimped end of this wire in place. So all you need to do is take a very fine pointed item, press them down and pull the wire out. Once you've done that, it's simply a case of putting a twist in this ribbon cable so that then when you put the connector back on, everything will have shifted places. So the first pin on the left is going to be the first pin on the right. Now, when I was trying to spec the parts for this dust sensor, I did worry about trying to get this length of cable and a crossover version, but actually the sensor itself came with the ribbon cable in the box, so I just had to make those changes. And in terms of fitting it in place, just folding it over gently ends up with quite a neat result, I think. The next 2 sensors are both quite similar. You have one that's a VOC, volatile organic compound sensor, and one that's a temperature and humidity sensor. The one that's at the bottom is the temperature and humidity sensor, and I think it's got this kind of pattern in the PCB to thermally separate it from the rest of the board. However, when you buy it, it looks almost the same. It comes in a packet like this. You have to solder these pins in place, and then it simply is a push fit into the connector at the bottom here. Just like that. The important thing for all of these boards is to make sure that your pins line up. Thankfully, the PCB has labels on it, as does the board. Simply slot it in place. So that means the other sensor is the VOC and NOx sensor. This gives you a VOC, volatile organic compound index, and a nitric oxides index, both of which are an indicator of pollution. Again, it's a fairly similar structure. You've got V in, which is voltage in, or 3.3 volts in this case, ground, and then 2 further pins for communication. The final sensor is a Sensair S8 CO2 sensor. This thing is quite cool. It will auto-calibrate itself and can give you pretty accurate readings. Check out the Air Gradient website for some of the research they've done on it. Now, I've mounted it directly onto the board. This is probably not the best way to do it, but the sensor is behind this mesh here, and all you need to do is take some header pins like this, solder them onto the board at the back, put the CO2 sensor on. Looks like this when you buy it, upside down, and solder it in place. With all the sensors now on the board, it's time to load the software. Plug in a USB-C cable here, the other end into your computer, and you have to use the boot button to set the ESP32 into a mode that is ready to accept software. I'm going to take you through all the steps we need to do to get this thing flashed with the right firmware, but we're going to do it in stages. The first thing, I'm here on the Air Gradient Build Overview part of their website. You probably know this bit already if you built one of their boards, because that's where you got the files from. So I'm going to take this version 9 board, go to the build instructions, and let's scroll down to the firmware part. Like I said, we're going to take this in a couple of stages. I think it's worth flashing their firmware first because it's set up to get you going. You don't have to get to the final product with all the custom integrations and Bluetooth tracking that we'll talk about later before you even got it working. So holding down the button, plugging in the USB to my computer. You see it's setting up a device, and then in a second it should appear and we can connect to it through the browser. Okay, so the device is ready. It's hidden underneath my face down here. Let's go to Flash now and see what appears. There you go, USB JTAG serial debug unit, and that's on COM7. So we'll connect to that. And let's see what happens. If you've used ESP Home before, then that kind of view is pretty familiar. So let's install Air Gradient 1 Open Air version. I'm not going to erase the device. I am going to erase the device. I can't remember what's on there. Click Next, click Install, and just wait for it to do its thing. It should only take a couple of minutes, so I'm not going to bore you waiting. Let's come back to it once it's done. While that's happening, you might notice every once in a while the CO2 sensor is going to flash. That's completely normal. That's just part of how it works. So remember, if you are going to be installing this anywhere with a 3D printed case in a very light color, you might be able to see it at night. It's really not that bright, but just be aware. Okay, installation complete. That's it. So let's make sure that it's all set up, ready to go. Let's connect to it, and then we'll get on to that next stage. Follow the rest of the instructions on the Air Gradient website, and if it's all working, let's move on to the cool bit. I've talked around it a lot already, but the extra bit I've added is Bluetooth tracking. The ESP32 has a Bluetooth radio on it that you can use to triangulate people in an area. If you've got more than one of these boards, and I've got them in many different rooms, you can use the relative signal strength from each board to figure out which one you're closest to and hence which room you're in. Quite useful if you want to know if someone's in a certain room to dim the lights or if they've left to turn them on. It's almost like GPS but inside your own home, and with all these air sensors everywhere, I've got pretty good coverage. The way we're going to set it up is via ESP Home. That's essentially what Air Gradient are doing, and using your own custom firmware, you can bypass their servers, which you may or may not be interested in doing. But I'm going to walk you through the process. You can probably guess it involves something to do with web.esphome.io, and yes, same thing as before. Press and hold that reset button, plug the board into your computer, and then you should be able to connect to it. Hey, there it is. Click Connect, prepare for first use. Again, this looks very familiar. It's going to install some generic ESP Home software. After that, we're going to do the same process of connecting directly to the board's Wi-Fi, setting it to your own Wi-Fi network, and then we'll move into Home Assistant and see how it's discovered. There you go, pretty quick. If you unplug the board and then plug it back in, within the first 30 seconds or so, you should see a Wi-Fi network with Air Gradient and some numbers after it. The password is clean air, and using that you should be able to connect to the device directly. There might be some issues because it doesn't have internet and your phone might not like that, but if you can connect and it doesn't automatically bring up this window, then just go to 192.168.4.1 and then you'll get the same thing. Just select your own Wi-Fi network, plug in the details, click save, and it'll reboot and connect to your network, I hope. I've unplugged the sensor and plugged it back in. It's now on the Wi-Fi network, and actually Home Assistant's already discovered it. I'm here on the ESP Home Builder part of Home Assistant, and you can see right at the top, one device discovered. There we go. That was the same bit of information that was in the Wi-Fi address. So once I've reset everything, I'm going to take control. I'm going to call it garden sensor, as I'm actually going to hang this one slightly outside the shed. It's outside, but I think covered enough to survive. I'm going to click take control, and then it should adopt into my version of Home Assistant. So once I've clicked edit, I can change the config that's on there. I'm going to copy this from one of my other ones. This is a flow and return temperature sensor. Yes, that's what it's for. It's for the boiler. So let's find the hallway, just so I don't get confused between the garden room and the garden air and the guest. So let's copy all of this and find my ESP home. Let's edit this. I'm just going to paste this version in here, and I'm going to change this one to garden. You can see there are a number of different packages here. These are the bits that tell the board how to read those sensors. There's an API connection at the bottom. I've removed my key, and there's a Bluetooth proxy. Now that's the really cool bit that allows me to use the Bluetooth triangulation to figure out where my phone is in the house. Otherwise, it's all fairly simple. If you've not used this before, then look at some of the other documentation online. This isn't an ESP Home video. I'm going to paste my key back in there, and we'll send it over to the board. Now it's time to install my custom firmware. This is essentially Air Gradient's version with the screen and LED indicator bit removed and Bluetooth proxy added in. That's the part that's going to tell us where we are in the house using the BLE triangulation part we'll come on to later. I've made a couple of changes here. I've changed the name and the friendly name, and I've removed my API key. You'll have to add yours in, and I will do too before we flash this. So let's get on and do that. We'll click save and then install, and then I'll walk you through the steps once I put my API key back in. There's a few different ways to upload this firmware. I find wireless is actually one of the more reliable ways, but if you've got it plugged into the computer you're working on or where Home Assistant is hosted, then you can do that too. As you can tell, this is going to take a little while, maybe 4 or 5 minutes, but it does talk you through what it's doing at the time. It's going to get all of the packages that you've specified, compile them into a custom firmware, and then upload it to the board. Once it's done, it should start spitting out some sensor readings, which let you know it's all working. Okay, it's been 5 minutes and this thing's still going. Let's go over there and talk about the 3D printed case. I've already talked about just how much I'm impressed by this case, and it's pretty easy to print too. It comes in 2 parts. There's a seam that is almost impossible to see between the 2 sides, and it fits on the bed of my Bamboo X1 Carbon really easily. Not together, unfortunately. I did have a couple of issues printing. You can see that this one has lifted up in the corner. I think that was my fault because this thing is a really good printer and every other case came out perfectly. I'm not paid to say it's good, by the way. I can say what I want about it. Oh, and I want to say it's good because it is. Although if you do want me to say it's good for money or another 3D printer, I'll happily do that. Look, I've got extra AMSs. I like this. This is good. Of course, if your board disconnects during this process, you can just click retry and it'll be a lot quicker. About 23.5 seconds, I reckon. Promise this is the first time I've done it. Okay, so we've had a lot of fun waiting, but now our garden outdoor air sensor, let's ignore the YAML name, has appeared in ESP Home Builder. If we go back over to settings, devices, and then go to our ESP Home, we have 13 devices now. Garden outdoor air sensor, which is not actually outdoors, it's sitting here on the bench next to me, has picked up some data. This is exactly what you'd expect from a room that I'm sitting in and not ventilating all that well and breathing in. At this stage, we've essentially got back to where we were with the air gradient sensor, except at the moment we're not uploading to our air gradient dashboard. I don't see a reason to for me. And what we're going to do next is the setup for the Bluetooth triangulation. Again, this is all in Home Assistant. To get this working, you're going to need to install Bermuda BLE trilateration via hacks. Now, I'm not going to go into the details of this. This is already getting quite technical for a Maker video, but if you want to go into the technicalities of Home Assistant and hacks, it's a really interesting rabbit hole, and if you're interested in what I do, then leave a comment down below and put Home Assistant, and I'll maybe make a video in the future. Now, the interesting thing you can do with this is create custom automations. For example, if I know that I'm in the living room, I can set the lights to my preferred level, but if someone else is there, I can set it to theirs. It really does open an interesting world of possibilities in terms of customizing your experience in your home based on where you are. The big question now, though, is What do I do with that data? Well, the first thing I always think is turning data into useful information, and for that I'm just going to give you a sneak peek at my air quality dashboard. I've got all of the different areas set up in the house and outside. I can look at it per metric to see if one room has a lot of humidity or maybe is full of dust, and then graph it. I love graphs. So do you. I'm sure if you're watching this, then you're sad like me and love graphs. But even better than a graph is a heat map. You can tell a lot of interesting things and visualize the data. But after that, it's up to you. You've got to figure out, what does that information tell you about your home, and how are you going to do anything with it? Does it mean that you turn on some air purifiers, open some windows? Turns out the air outside is actually a lot better than the air inside, at least for me. But is this the right route to take for you? Well, let's see, was this all worth it? So, was it worth it? If you're only going to get one sensor, then probably not. Go to Air Gradient and buy one. It's going to be cheaper, it'll be a lot easier, quicker, and it just works. However, if you want to create a whole network of sensors in your own home, or you want to use some of the extra features on the board, or want to use slightly different sensors, then yeah, go and get your own ones made. It is worth noting that getting the PCBs on their own, without the headers and the chips added on, is going to be a lot cheaper. Remember, you're having to pay for the component, someone to be able to source them, and then the time to add them on. If you've got a bit more time and a bit more skill, then just get these. You could get 10 for not a lot of money, and then populate as many as you need. You can always have some spare for the future, or if you make any mistakes. That being said, if you do want to get something a bit closer to this, then I can thoroughly recommend PCBway. Their engineers were really helpful throughout the process, and it was pretty quick. They had a few questions because this isn't exactly perfect when it comes from the file on the Air Gradient website, and while I'm not an electronics expert, they were able to help me troubleshoot it and get the board ready for production. If you're interested in this sort of smart home, electronics, building things, then you should probably follow me on Instagram. I release a lot more stuff over there and show you some of the behind the scenes, including this shed and that CNC and whatever the hell that is. However, if you do want to see more smart home videos, then leave me a comment down below and I'll see what I can do. I've got a few different things here that might be interesting, as well as some big smart home projects coming up. Anyway, I'll see you on the next one. Thanks so much for watching.